So, let's move to community questions, shall we?
Yes, sir.
Chris F. is asking, when professional marketing team, what happened with all these funds? And I guess he means all the funds spent on marketing in the past.
So, if we go back to chapter 2, it's kind of ironic. Part of the goal of that was to hire a professional marketing team. And that's the irony in it, because what we're seeing right now is cryptocurrency is a different type of marketing altogether. We've seen some slapstick marketing. We've seen, Wendy went out there and didn't really represent things properly. So if you see the articles that have been coming out more recently in the new content we're developing, we're working on a more educational approach. I think the definition of professional marketing is a very vague definition in a new industry. So that's been part of the challenge, is how do we get back to those original roots of organic growth that we've always seen. And that's the pursuit that we're doing now. So right now we have different working groups inside each different embassy. We have a content working group, and then a branding working group, and then a strategy working group that's developing these overall higher level strategies. So the ultimate thing, I think, is getting as much community feedback as possible, being as open as possible, and developing that bottom-up structure as well, to have people that want to volunteer and contribute help it organically grow. Because the marketing, as we've seen from the beginning, people have constantly criticized it, and we've attempted to try to make it more professional by hiring people that we thought were going to be professional, and they obviously didn't have any idea of what to do. So there was money spent. Those are lessons that have been learned. But as we're moving forward, I think developing this marketing strategy more and more with the community in an open, transparent way, and getting the positive feedback will help us be able to tailor the message in a way that really helps. And honestly, I believe that marketing in itself doesn't need to be the way that we think it should be, as far as we're going to go out and we're going to try to sell this product, because what happens when we try to sell something is people end up selling. And that's not what we want to have. So yeah. I believe just the natural roots that we've always had, is you yourself said, Mirex, is we used to be this voluntarious, group of people that just went out and talked about it and educated people on it. And that's what I think we need to be focusing on. And the other side of it is the business development, which, we have quite a few people working on that. That's marketing in itself, because that provides viability and use of the product. And I think that's the best way that we can show people what we do, rather than telling people like all the other cryptocurrencies do. We show them, this is what we've done and this is what we're doing. And people naturally talk about that. And I think that's going to start to create that positive snowball that we've been really looking for. So removing the idea of marketing and starting to change that to more education and use cases, I think, is going to be the way we're going to see some of the positive reception.
Yeah, I of course watch every news and articles and the development. So from my point of view, I can say that the direction now looks very positive.
Good.
And Andis asked a couple of questions. What Nexus community governance is about? The first question.
Community governance. So that's kind of an architecture that's been developing, I think, about 6 months now. It's essentially what we call a social stack. So as we've seen, governance in cryptocurrencies up to this point have mainly been stake-based voting. What we're doing is we're developing different voting groups where people that contribute different resources can have a different voice correlated and collected as one voice together. Because I think one of the biggest governance issues we've seen in cryptocurrencies and anything is that you try to throw too many people together with varying different perspectives. Like, let's say developers having the perspective of a block size increase and what that means to them, versus traders that just want to be able to exchange value quickly, or exchanges that want to provide a good service to people. So I think as the way we're designing the governance system, we're doing it very slowly and we're doing it methodically because it's going to take a while. It's a complete new architecture that's never been done. The world really only has a model of centralized hierarchical systems to function. Now, hierarchies are half-truths, and so is straight, pure anarchy and decentralization. And what I mean by half-truth is a half-truth carries portions of it to be true, but portions of it to be false. And we've seen half-truths live for eons because they're impossible to detect.
Okay, I have to interrupt you right there because another two questions are very related to what you just said.
Okay.
How voting eligibility will be determined in this governance model, and how creation of fake accounts will be prevented.
Okay. So I'll just continue a little bit on what I was saying earlier to kind of bring context and color to that. Hierarchy is a half-truth, and so is pure anarchy. And the half-truth of hierarchy is that nature is built in layers, and that the layers do function to scale, where you aggregate data through levels. Now, the half-lie is that it's top-down, which means somebody from the top appoints down this pyramid, and they control everything below it. Now, with decentralization, the half-truth is that it's built from the bottom up, that it's the base that decides. And the half-lie is that it's perfectly horizontal. So with our stack that we're developing, it's a bottom-up stack, which means those that rise up, they rise up on merit through a meritocracy. And the very top of this is where we have the DAC, and that's the validation layer. So how do you become eligible to get a vote? You become eligible to get a vote by contributing resources. Well, how do you prevent people from creating duplicates? You have a reputation system that's built in. So one of them would be kind of a L1 validation trust, and then the next one an L2, and the next one an L3, which would be the first level, people that are going in and validating the transactions on the 3DC. The L2s would be the people that are doing a type of proof of stake mechanism. The L3s would be the miners. And then the other two would be the developers and the ambassadors. So the way you give people weight to a vote is from their time they contribute and the consistent weight they contribute over that time, which develops your reputation and your trust. And then, of course, the last one would be kind of an L4 identity layer, which that's going to be a little bit more tricky to be able to define because you have to measure normal behavior against itself. If you have no common baseline to measure something against, then it has no form. So in this sense, with the L4 kind of identity layer, is we're going to have a normal interaction of events that creates a person. And then that interaction of events is measured against another one, and the natural entropy that happens from people doing their normal day-to-day things is going to provide, I guess, that baseline to measure yourself against to see how reputable or trustworthy it is. But long story short, how do you prevent that from happening? You make it require a certain amount of resource. And if people don't really want to have any of that contribution to the network, the validation process, or any of that, then those are going to be the people that generally probably aren't going to have as much of a voice. So it's going to require some sort of contribution, because those that put their sweat and blood into it are the ones that are going to be the one, I think, at least having more proficiency in the ability to make decisions in the best of the whole.
All right, and last question from Andy is quite long. Let me read the whole thing. Tritium Trust white paper states proof of stake inflation will likely fall in line with the other two minting channels, 1%. Why POS reward are distributed as 0.5 up to 3% interest payments dependent on trust, instead of distributing like in POW channels 1% per annum to always stake dependent on amount of coins and trust? Are there some technical difficulties or ideological reasoning behind it? Does it make any sense to you, this question?
The question's a little bit vague, but I'll do my best to kind of answer it in the best way that I understand it being presented. Is that why do we want to have trust to be that which builds your percentage up as far as your ability to get 1%, 2%, 3%? Well, that's because we want to reward people for consistent contribution. So part of the L3 trust, like I was explaining in the previous question, is that the miners are going to build up a trust as well, and that's going to define their total amount that they mint, because what we want to do is we want to have people that are contributing to the validation process, people that have been doing that consistently. Right now, in conventional proof-of-stake designs, there's no reward for consistent behavior, where consistent behavior does develop a higher level of reliability and you want to have more miners that are consistently mining the network rather than people that are hopping on and off. So that's one reason that we do it as far as the trust and the trust levels. Now, as far as that correlating to why is it 1% comparatively and why isn't not just like a proof of work where you can just join the system. Proof of work is just a momentary resource input that you put in and you get a selection or a piece of that. But the trust system is something that you can't just come in and hope to get a lot. So that way you it's almost karmic. You get back the more you put into it. So that's at least the design of it. And I guess
I think what you just said is pretty clear.
It's very clear. Okay.
We can move on. Captain Slow is asking, what steps are actively being taken to open source the Tritium software? What kind of outside code reviews, if any, have been done on the development so far?
Okay, so the steps to have it open sourced is when it's released, it's open source. So until it's done, that's why it's being kept in a closed source repository for people that need to know to be able to see it, to do code reviews. So we've had analysis, static analysis, as far as security analysis done on it from cybersecurity forum in Arizona, and we're also employing another one out of California to make sure that there's no security holes, things that are found. So other developers as well that are helping develop the code are doing reviews, and anybody suggests would be a trustworthy person or somebody noteworthy to review the code is definitely welcome to review the code. I know Dino Farinacci has reviewed the code substantially, Victor Moreno, Blackjack, any of the other people that have been there have reviewed it, and I've had a lot of positive reception on how readable it is, how well organized it is, and so as far as that's concerned, that door is always open, and if there's any suggestions for more people to review the code, I'm always open.
Sound great. Trey is asking, can you ask him if the March launch will be using a vector rocket?
Yep, it's using a vector rocket, and it's actually paid for in Nexus, which is really cool and very unique. So that's our 1U. And so we have the launch contract already set, we have the satellite already purchased. Right now our slow point is the frequency licensing. So that's a little bit more expensive part, but yes, it's going to be on a vector rocket and it's paid for in Nexus as well as the satellite itself.
Okay, and Trey also included this message for you. Also forward this to him for me. America wasn't the first country to put a man in space, but America dominated the space industry for a very long time. It's not a who did it first race, but who did it best. Good luck with the next year.
Cool, thank you, Trey.
Let's move to another question. User Rubix is asking, hi, I would like to know if the dev is considering a mobile wallet. Thanks, cheers.
Yep, so with the framework that we developed for our logical and interface layers, it's built in React right now. So React is very easy to port to a mobile device. So essentially all that's needed for a mobile wallet will be a Tritium Lite backend node that is coupled with that, and then to just use React Native to either put it on iOS or Android. So that's definitely a part of it, and it's going to be very streamlined with the actual look and feel of the desktop wallet.
Yes, and now we have one very disturbing question from Wilcat Powa. I think mainly for a lack of knowledge in electronics and crazy future he described in the question. So, could we identify everyone on Earth with the signature chain in the future through a microchip they wear and communicate with the satellite's Wi-Fi? This way nobody could hide behind a false identity?
Okay, so the concepts of that have some merit, but the implementation of that is definitely not something that I believe would be in benefit of people. The concept of it is your inability to spoof or pretend to be another person. That's going to be built in natively with the signature chain. As far as your EID coupled to your signature chain, nobody's going to know exactly who you are, but they're going to be able to see the reputation that you have exhibited. So you're going to know if I'm talking to you, Mirax, I'm going to know your Genesis ID because you have shared that with me and I know that that's you. So therefore I know that I'm talking to you and not somebody impersonating you. But nobody else needs to know I am me and you are you. So we create levels of privacy with that, but our ability to still identify each other by having our own private communication in the way that we identify each other. The important part of that as well is that we'll be able to open direct peer-to-peer connections to one another. I can look up your SIG chain and talk to you directly through your Nexus wallet or whatever let's say, application built on top of that. So the chip thing, I definitely would stray away from having identifying chips that would link you to satellites and things like that. I'd also say that you don't want to have biometrics be your password, as you saw in the last signature chain article. A lot of people think, well, let's have something completely tied to me so that I can't pretend to be anything else. That doesn't always work. Your DNA is very easy to steal, so is your fingerprint. You can still coerce people into those things. So I think having the privacy aspect is very important, but also having the reliability and the security of knowing who you're talking to and knowing that somebody's not pretending to be somebody else is also very important. And I think we found a very good balance with that, with kind of the list BID along with your sig chain.
Okay, now we have a couple of questions from Christo. First is the longer. You said once 3DC is completed, a node won't have to store the whole blockchain or process all the transactions. So is it that kind of sharding? If it is, then how it is compared to the sharding solutions from Ethereum, Ziliqua or IOST? How will the level of redundancy be decided to balance between the scalability and the security/availability?
Okay, so the way the sharding is going to work, we do it a little bit different. You're going to have on a 3DC the L1 state channels, and that's where you create the parallelism and the shards. So they hold their own transaction ledger. And what happens is, since a transaction is assigned to that signature chain or that state channel by their signature chain through a level of entropy that's difficult to be able to forge, a conflict, if somebody was trying to do a double spend, would be identifiable only in that state channel. So this way we don't have to have the shards cross-communicate. And when they pass up to the L2 layer, then you can resolve that. So that's how you get the security of the sharding, because a lot of the problems that we have with sharding and the ideas of it is that all these different shards can maintain their own transaction ledger. But if you have a conflict, then the shards have to talk to each other, and if the shards have to talk to each other, it degrades into the same situation because everybody has to process everything to check everybody. So you get the redundancy by having a certain number of nodes assigned to each state channel. And the more nodes you have in there, the higher amount of redundancy you have. And then from there, after you go through, let's say, and get to a checkpoint, you're going to have archive nodes that are going to be able to hold a lot more of that state, so that nodes are only going to need to process so much on the first levels, and those and the L1s that actually process the data are going to be required to hold that data that they process, since they got paid for doing it. And the way that our shards are also going to work is, as I was explaining earlier, with a different type of IP system that we're going to be developing with Lisp, that's going to allow you to just open up a TCP/IP connection to the index of whatever you're needing to find, and nodes will essentially join as RLOCs available, and then you round robin to each one of them to get that redundancy and availability as well. So the network itself will be able to maintain and know how many are holding the state of that data, and be able to maintain a certain number of nodes keeping that, so that you get that redundancy and the scalability, obviously, because they don't always have to talk to each other. When the L1s can operate independent of one another, and you have, let's say, 1,000 nodes doing the processing on each one, and conflicts are going to be identified in that channel and passed up to the L2 to be resolved, because the L1s will have the authority to do that. You get the security and the scalability because they don't have to be doing all the actual transactional level signature processing. They can just be resolving simple things, and then the miners on top of that that are going to secure and finalize that data. So through the aggregation is another way that we get that scalability, but it creates a tree all the way up to the top in the root hash that you'll be able to define. If you want to go ask for data from somebody else, you're going to be able to follow that tree and make sure that it has a valid path.
Another good question from Christo. What will be confirmation time after 3DC is implemented? Will the old 50-second block time remain?
So it's actually, instead of it being a 50-second time based on the difficulty, it's going to be a 1-minute span for the L3 lock to be finalized. So it's really going to depend on what level of confirmation that you want to accept. So merchants already now deal with a large amount of chargebacks, they deal with fraudulent transactions, and that's still a large percentage of their income stream that they have to deal with already. So it's instead going to be, I guess you can call it a scalar decimal number rather than 1, 2, 3, 4, 5 like we have in a conventional blockchain. So what's going to happen is when the transaction is broadcast into the state channel, it's going to be included in kind of a small minor state block, that those are going to be linked together. And then the amount of time that that transaction's been there is going to be part what contributes to that number. So it could be 3 seconds, it could be 5, it could be 10, it could be 20. It depends on what that merchant decides to accept as valid, which gives people better indicators instead of 0, 1, which is how we have with Bitcoin, which means it's a 0 confirmation transaction for 10 minutes. If you're lucky, it's going to be something that's going to steadily increase, because the more time that that's already been witnessed, the more nodes are already going to have signed off on that, and the less likelihood there is going to be for a conflict to be broadcasted in. Because if I were to be an attacker, since you have a signature chain on your next hashes, you have to claim the same next hash, which means you have to claim the same piece of the transaction, and since that goes into the same state channel, the merchant will be able to detect that very easily if I've sent a transaction and then I sent a conflict, because they're going to be running in that state channel verifying that, because that's what you essentially broadcast it into. So based on that, it's going to be much easier to determine these things. So I don't really have the number exactly. The full block confirmation number will be 1 minute. You could wait 2 minutes. I generally recommend that, higher value transactions should be waited for a number of minutes, just to make sure that you don't have any of those. But the more microtransactions will probably be less than 5 seconds, less than 3 seconds, depending on really what level of risk the merchant wants to assume.
Following question from Crystal. If Nexus transactions will be free, then how will we prevent spamming transactions? For example, someone requests to store a very large amount of data in the blockchain.
Well, registers are going to be the only way you store the data, and the register is going to have a limit. Now, since it's SIG-chain based, a SIG-chain requires a series of transactions. Think of a SIG-chain as almost a blockchain in a blockchain. So whenever I make a transaction, it's going to be very easy to determine, okay, well, I've made 2 transactions in the last 1 minute. What you do is you just apply a certain proof of work required on that specific transaction. If your speed has increased enough, so you look at the previous transaction and the time it's been, if it's within the grace period, let's say 5 seconds, 20 seconds, 50 seconds, whatever we define that constant to be, you won't require that proof of work. But the more that you decide you want to drain from the network by making it do processing, the more processing you're going to have to do yourself, which that's a natural way that we can prevent these types of spam attacks or even DOS attacks that are going to be happening. That's one thing we're actually working on with Lisp as well, when the mapping servers, is you're going to be required to do a certain amount of proof of work to do your request, so that the more you load down the server that's providing that service to you, the more you're going to be required to contribute. And since it's asymmetric, which means it takes a lot of work over here but not much to verify it, it doesn't take much off of the map server or any other service. And so that's going to be the natural way they're going to be able to prevent these types of things. And obviously by limiting the register size, we're going to limit your ability to attack. Because if somebody really wanted to attack and it's a small transaction fee, we've already seen people in Bitcoin, they do it because they have plenty of money, they have plenty of Bitcoin. But computational resources are things that are a little bit more difficult to get a hold of.
Okay, let's move to last question of Christo. What do you think about blockchain trilemma? Decentralization, scalability, consensus. Has Nexus solved the trilemma?
That's the plan with the 3DC architecture, because right now, I mean, Ethereum, they have the decentralization, and they focus mostly on the decentralization rather than the scalability. But we believe with having these state channels and the data aggregation going through them, that we're going to be able to solve that. Now, obviously, we don't make claims until things are finalized and put into place, but the sharding and the distribution of the actual resource requirements is what we believe is going to help that. And then the reputation system is something that also contributes significantly into that, because you'd have to attack with an incredible amount of time, over time, in order to, let's say, be breaking this decentralization or this security by pooling your resources. And when you do that, you're going to lose that time as well. So the plan is to be able to solve this trilemma, and the abstractions on the stack also help as well. Ethereum has scalability issues because it's an over-complex Turing-complete engine. Think of a Turing-complete engine as almost like a microprocessor CPU. And we all know that ASICs are faster than CPUs. Because a CPU is generic, it can handle all different types of computation. Our stack is more like an ASIC, where there's specific applications that it's very good at, which just makes it very fast. So I think it's definitely possible to solve this trilemma. I think just the fundamental blockchain architecture is what's been limited.
Okay, and this about wraps it up for the community questions. Thank you, Colin, very much for this interview. It was a great pleasure to hear you. And is there anything above the scope of this interview you want to say to community, some message, some stuff?
Well, I'd want to say it, I guess in a way this is not as contextual to this specific interview, but it kind of deals with what we're looking at in the world. I mean, don't forget your roots, don't forget where we came from, and don't forget where we're going. As we see the crypto industry as it is right now, a lot of it's a joke, a lot of it's at war, a lot of it's dominating, and the original promise of crypto, at least in my perspective, was that we have a new way to think and a new way to do things. And I think that's very, very, very important for us to continue to hold and to make sure that if we have issues with one another, that we learn to communicate so that we can understand where we're coming from. And I think that understanding is going to create a greater growth, and that learning from chapter 2, we can't be at war with each other. We saw how much we have factions of people caring about the project and different ways of doing it. And if we can learn to hold together, I think it's going to be ever more necessary, especially with the way we see the world. There's enough of that, and I think we all need each other, whether we'll admit it or not. So don't forget that we're all in this together, and that, you know, I consider Nexus kind of like a big family, and I think that's a beautiful thing, and I think that's something that the world needs. And to just not forget that, you know, if you want to change the world, just start by changing yourself. And the more and more we change ourselves, the more and more that is going to spread. And I think with enough people doing that, we really can make a change.
Thank you for the closing message, and thank you for the interview again.
Thank you.